Hi, welcome back. In this lecture I would like to describe how to program the diffusion problem on a GPU using a simplified approach with PyTorch. By the end of this lecture you will be able to change a Python code using NumPy to use PyTorch and more specifically graphical processing units, in short GPUs. And also we're going to look at how to use a basic profiling tool from NVIDIA to monitor the GPU usage. PyTorch is a widely used deep learning framework that can use GPUs. At its base is a static computational graph tensor library that is particularly user-friendly, has a very intuitive API for anyone who is familiar with NumPy. So we'll be able to use PyTorch to substitute NumPy code. At its heart is a tensor library, and we're going to use in this particular lecture as a tensor library. So it has all the same functionalities as NumPy, with the added advantage of creating function through a so-called static computational graph. But what is a static computational graph? A static computational graph means performing operation on PyTorch object creates a dynamic definition of a program that gets compiled to GPU in the background when it is executed. So this is very much like the just-in-time technologies that we saw in JIT versus AOT compilers lecture. Since this is done dynamically, changes to the Python code automatically get reflected in changes in the GPU code without an explicit compilation step needed. So it happens in the background. Obviously, this helps a lot when debugging and we're working in an interactive way with our code. And this is a major advantage with respect to static graph libraries like TensorFlow. So let's look at how we can take our diffusion code that we design using NumPy and transform it into use a GPU. So the most important part is actually to import PyTorch and import these two functions, roll and zero, that we used for the GPU. So this is a major change. And then also we need to tell our code that we need to move our data to the GPU. And this is done in this simple call. So grid equal to grid.CUDA. So you can see that is exactly like we had for our code using NumPy. We have only two differences. Now we import a torch instead of NumPy, and then we tell the code to move data to the GPU by this call here. If we run a performance comparison between the CPU that is here in blue and the GPU that is here in orange, on the y-axis we have the runtime, so this is the execution time, and on the x-axis we have the grid size, so larger workloads. As you can see, for a small grid, the difference in execution time is quite small, but increasing the workload to the GPU, this improvement becomes larger and larger. So that means that GPU are quite good whenever we have a quite big workloads, right? And we can get quite a big speed up compared to using CPU. Finally, I want just to briefly mention a simple tool that we can call. It's called NVIDIA SMI. So we can do NVIDIA SMI Python and then our diffusion code.py, and we will get from the command line this information. So there are two major information. One is actually the power that has been consumed. In this case, 96 watt over the 260 watt available from the GPU, and also the GPU utilization, in this case 95%. That is the time that is used by the so-called GPU kernels to run. This is the last slide. So to summarize, we saw how to use PyTorch to have a simple port of a Python code using NumPy for a GPU. So we start from NumPy code, and then we import Python and is readily use GPU system. This is the last slide, and talk to you soon.